Hello and welcome. In this video I'll be talking about the DocShield application, which has been available for some time. This app is a Tornado Bismuth crystal, extending the functionality of the Tornado Bismuth wallet. Before showing and demonstrating the actual DocShield application, I'd like to explain its functionality and potential use cases. Let's start with the DocShield functionality. Of course, first you have to open up your Tornado Bismuth wallet and activate the DocShield crystal. After selecting the file, the app will automatically create a hash of the file, which you could also call fingerprinting the original file. As you might know, once a hash of a file is created, and then you try to change the file, even if it's only 1 pixel, the file hash will also be completely different. Now that we have the fingerprint of the file, we will store it on the Bismuth blockchain by creating a transaction with the file hash saved in the data field. Now anyone can prove and check that the hash and the corresponding file are immutable. Let's look at some potential use cases for this app. Now on top we see the public blockchain, and beneath is the user. Whenever a user achieved any kind of qualifications, for example, certificates or diplomas from public services, schools or universities, and then wants to prove to a third party, for example, to a future employer, that the digital files he has sent to the third party are indeed original or unchanged and released by the entity which the user is claiming. Now the potential employer is capable to verify that the file and the hash match and that the hash has been stored on the immutable blockchain by an address which officially belongs to the entity which released the original document. That means that we have the employer could check if this address where the hash is stored on the blockchain really belongs to the university or the public services when they publicly announce their addresses. Then that's indeed possible. The service, for example, the schools and the universities, they publish the hash on the blockchain. And now we have everybody is capable of verifying that the file hash really is connected to the original file. This way, the employer does not need to contact the university or the school or the public services. They have the hash and can verify it themselves. Note that the original file itself is not stored on the blockchain, just the hash or the fingerprint of the file. The blockchain is public by nature, and since only the hash is stored on-chain, anyone else who does not have the matching file or is not involved at all doesn't know what the hash is about. This way privacy is preserved. Now let's switch from the theoretical demonstration to the practical part and start fingerprinting a demo file. Let's assume that I represent an entity that offers training programs for space travel, and this particular Mr. John Doe successfully completed the training program requirements. The participant will receive this PDF file along the hash, which will also be stored on the Bismuth blockchain. Alright, the task is now to store this PDF file on the blockchain using the Tornado Bismuth wallet. I am now using this hyperlink crystals, and then first I have activated already the DocShield application, and then you will see here on the left sidebar the DocShield application. This is the DocShield application. Now I'm going to load the document. Here's the certificate .pdf, and you see that the hash is automatically created. It also tells us the file size, and now we are ready to submit the transaction to the blockchain. This is now the first transaction. This is the address I am sending from. I'm confirming and send the transaction. And I'm also sending the second transaction, which is in using the JSON file format. All right, while we are waiting now for the transaction to be confirmed on the Bismuth blockchain, we will check the hash of that file manually via the terminal. Right, I'm now here on the terminal and I see on the right is this PDF file I want to check. And I could also manually check it, and that's what I'm going to do now. Show some algorithm, and the algorithm is 256. And then I just have to tell the name of the file. And you see this is the hash, the 256 hash. It starts with A66 and ends with 9B7. And that should be the same, A66 and 9B7 is in the end. So that's correct. And now if we head over to the Bismuth Explorer, we will see the files on the blockchain already. You can also see the transactions if I click the DocShield again. And here you see we have those files. We did two transactions. Once is the first one is the JSON format, and we can see what's on in the Explorer. It should be using the data field or open field, and you see that the file hash is right here. It's a hash type SHA-256, and then it's also showing the file size and file name. And the other transaction is only the hash of the file. All right, thanks for watching.